All right, let's use our graphing calculators to explore both horizontal and vertical translations of the sine and the cosine curve. All right, so what I'm going to do is I've pressed y equals here. Well, actually, first of all, press the mode key and make sure that your calculator is in radian mode. And just about all of the graphs you'll see in the homework have radian measure on the x-axis, so we want to be consistent with that. Next, I'll press the y equals key, and I'm going to go ahead and just graph y equals sine x. All right, and I want to put this in an appropriate window, so I'm going to press the window key here. And I want, typically we've graphed these graphs on an x-axis that has gone from negative 2 pi out to positive 2 pi. And we've seen 2 complete cycles of the sine function by doing that. So I'm actually going to use the pi key to set the window to go from an x minimum of negative 2 pi, and pi is just second up caret. So notice the symbol there, and now when I press enter, it'll give me the decimal approximation to negative 2 pi. I want my y max to be 2 pi. And we've been using increments of pi over 2 on the x-axis, so I'm going to choose that. So let's call this pi divided by 2. All right, and we know that our sine wave has a maximum value of 1 and a minimum value of negative 1, so I would choose y values appropriately. I want a little bit of room to shift this graph up and down, so I'm going to go ahead and make this negative 5 to 5, and I'm going to use a y scale of 1. The rest of these really don't matter that much, the rest of these values, so I just kind of ignore them. And if I press graph, I will see 2 complete cycles of the graph of y equals sine x. Notice my tick marks are on the graph at every pi over 2 radians. So this looks a lot like the graphs that I've drawn by hand in previous videos. All right, now I just want to illustrate that if I add a constant onto the end of this function, so if I type here, let's make this sine x plus 3, and I can actually, the nice thing about my computer calculator, I guess, is that it'll change the colors. I think this is going to graph in red. And so when I press graph, I see in red that the number plus 3 on the end shifts that entire graph up 3. If I graph y equals sine x, let's just say minus 2, I will see a graph in black that is shifted down 2. All right, so I know that if I add a constant to the end, I guess, of the function, you can say, that is going to be a vertical shift of that function, either upwards if my constant is positive, downwards if I'm subtracting or adding a negative value. So that's fairly straightforward. All right, let's take a look at what happens if we add something to the argument of the sine function or the input. Add and subtract from the input. And when I say input, I mean x. So this time, my red graph is going to represent the function sine of x, and I'm going to subtract a multiple of pi. Remember, our x-axis represents radian measure. And so when I shift this thing left or right, I like to do it in multiples of pi so we can kind of see what's happening. So I'm going to subtract pi over 2 from x. Okay, so my function is y equals the sine of the quantity x minus pi over 2. And my red graph now I see there's my original function is shifted to the right by pi over 2. So notice that my initial graph goes through the point 0, 0. This red graph, the shifted graph, now goes through the point pi over 2, 0. Right? And although inside my parentheses I see the value x minus pi over 2, this is a shift to the right. Okay, so if you think about it, let me just write here for a second. You know, we have our let's just kind of increase the scale on this. So, you know, here's my sine wave, y equals sine x. Looks like this. All right. And I can let's refer to the 0 here at pi. So there's a 0 at pi. Why? Because the sine of pi is 0. And if I want to know the corresponding 0 in the function, the sine of pi minus, the function, the sine of x minus pi over 2. All right, so I know when I look at this relationship, the sine of x minus pi over 2 equals 0, I know that this x minus pi over 2 equals pi. Why? Because the sine of pi is 0. And when I add pi over 2 to both sides of this, I get x equals pi plus pi over 2. Sorry. And pi is just 2 pi over 2. 2 pi over 2 plus pi over 2 is 3 pi over 2. So this 0 at pi gets mapped to 3 pi over 2 in the transformation, which means that this graph is being shifted in this direction to the right. Okay, so in general, when I see something like this, you know, the sine of some value like this is my function. I'm writing it like this. This guy is what we call the phase shift of the function, and a phase shift means I'm going left or right. And you know, my phase shift, if this constant is positive, is going to be to the right. If I see x minus this will be the phase shift to the right. If I see x plus the phase shift, it'll be to the left. So it's kind of in the direction, the opposite direction from what you see in the equation. All right, so if I share my calculator here one more time, and we look at just one more to make that clear. All right, so let's look at the sine of x plus pi over 4. Okay, so my phase shift is going to be in the opposite direction of what I see. All right, so it's going to be the opposite of what you see in the equation, and in this case it'll be left pi over 4. So I should see that black graph actually compared to the blue graph is shifted left by pi over 4 units.